All right, turn to page 10 and pause the video here and see how much of the warm-up you can get done by yourself. This is really good beginning review of the first two topics for the quiz coming up. So if we have an initial point, I'm going to call this one A, and a terminal point, I'll call this one B, component form for vector AB is terminal minus initial. So 4 minus -1 for the x, 6 minus 2 for the y. So that gives me 5, 4. For direction, I actually need to know which quadrant the vector's in. So 5, 4, that's going to be quadrant 1. So your direction is actually the result of your tangent inverse. It's not just the reference angle. And since I'm doing this video at home, let me figure out how to get a calculator. Okay, we're just going to do it this way. Whoops, sorry about that. All right, so first off, make sure you're in degree mode. This one is not. So then I'm going to type second tangent y over x, parenthesis, hit enter, and we get 38.66 degrees. Magnitude is the length, and that is the square root of x squared plus y squared and the square root of 41 is irrational, doesn't have a nice integer or rational value, so we're just going to leave it square root 41. Now for this next question, we're given component form because these are square brackets, or pointy brackets, excuse me, versus here, this was a point with the curved bracket. So when you have a point, you go to component form. When you're given a vector, with the notation of the vector brackets, you know you're already in a vector. So this says find vector u minus w. So I'm going to do 1 minus -5 and 4 minus -6. It has to be vector u take away vector w. That order matters. These lines mean magnitude, so that's going to be the square root of 6 squared plus 10 squared. And then the direction, the vector 6, 10. Oh, it's also in quadrant 1. So the tangent inverse of y over x gives me the actual direction since it's a quadrant 1 vector, and that is 59.04 degrees. Okay, so our new topic today is going to be operations with vectors graphically. The way we ended the warm-up, that was operations with vectors in component form. When we have diagrams of vectors, there's two methods for adding or subtracting them, a triangle method or a parallelogram method. I like to use the triangle method, and the way the triangle method works is you can only connect your vectors from the initial point and a terminal point. Regardless of which method you use, the result is always the initial start, the initial beginning, to the very end. Okay, so let's look at number 1. We have vector QU, so take your pencil, we're going to start at Q, we're going to end at U. And then I've got UI, so start at U, end at I. So what's happening is I notice here I have the terminal point and the initial point already lined up. So you can think of adding these vectors graphically kind of like giving someone directions with a shortcut. If we start at Q, go to U, keep going from U to I, the shortcut would have been to start at Q and end at I. So the result is the vector QI. When you have subtraction, that just means backwards. So when I have a subtraction problem, I would rewrite that as adding the opposite vector. So number 2 is really asking us to do vector CN plus NQ, the other direction. So we've got C to N. Okay, so start, terminal. Instead of Q to N, backwards, I'm going to add N to Q. So start at N, end at Q. The shortcut would have been start at C, end at Q. So all of your answers are the result to start at the original start and end at the final end. Okay, you pause the video, you try number 3. I'm going to start at Q, go to C, continue from C to U. So the shortcut would have been start at Q, end at U. All right, for 4, before I do anything, I'm going to change the subtraction. So this problem is really asking CI plus IU plus the backwards, so Q to U. Okay, so we've got C to I to U, U to Q. So if I notice, I've got all the terminal and initial points lined up. So now here, the original start is C, the final end is Q, so the shortcut would have been just to go from C to Q. All right, let's see what's on the next page. All right, so this is different notation. So on the page before, we had 2 letters to show us our vectors. Now in all of these diagrams, it shows us that A is this side of the parallelogram, B is the bottom leg, but specifically going from this corner to that corner, there's the direction arrow. And so let's refresh a little bit of these parallelogram properties. In a parallelogram, opposite sides are parallel, meaning they have the same direction, and opposite sides are equal in length, meaning they have the same magnitude. So if this is vector A, from this corner to this corner is also vector A. If this is vector B, so is the top part from this corner to that corner. Another property of parallelograms is that diagonals bisect each other. So this segment C, this vector C, is equal to this vector C here, and this vector D is equal to this piece D because the diagonals intersect each other in the middle. They're bisected. So we can translate these vectors anywhere we want to create a smooth path. So for example, we've got C, which is start here, end here. Add that to D. Well, here's the issue. If I use these vectors as they are, they line up at terminal, terminal. You can't move on the path of vector C, teleport yourself, jump down here, and move vector D. Instead, I'm going to take vector D and translate it to this piece of the diagonal. This is also vector D. So now the shortcut, if I travel C and then D, the shortcut is vector A. Minus means opposite, so I'm going to think of this as plus the negative direction. So if D is pointing up and to the left, opposite direction D is going to start here, and the terminal point would be in the opposite direction. So we're going to travel vector C. Terminal and initial line up, so then we're going to travel opposite direction D, and the shortcut would have been B. All right, let's try 7. We've got vector A, initial terminal, vector B, initial terminal. Can't add these together when they're lined up, terminal point and terminal point. Pick one of them to translate and slide. So because I'm still holding my pink pen, I will slide vector B up here. So now we can follow the path, initial to terminal, and the result would have been start here, end here. So we've got vector C. This is also vector C, so that's 2C. We have that scalar multiple, C and another C. All right, for 8, subtraction means plus the opposite. So vector A starts terminal, opposite B. So instead of the terminal being on this side, this is now the initial, and the terminal is on this side. Well, that works out because now if I think of the shortcut, here's an initial point, terminal to initial, so I can keep going. So if this is the original start and this is the very end, the shortcut would be 2D. Okay, you pause the video. You try B minus A. All right, so B minus A is like adding the opposite. So start here and end this way. So if this is my initial point, I'm going to travel the opposite of A. That lines up, and I can continue on the path to B. The result ends here. So this vector would be the result. Notice the arrow or the direction of D is pointing up, and I need to go down to the right. So that's the opposite direction, a negative, and there's 2 of the D vectors. All right, let's try 10. 2C, that's all the whole diagonal, plus the opposite of A. So that would be this direction. You could also think of it as over here, this direction. This vector and this vector are equal, same direction, same magnitude, same vector. So regardless of which one, I'll start on this side. So if this is my initial, this is my terminal, this is the result. Since the bottom piece here is labeled B, this is also vector B. It would have worked if I did this direction too. This is my initial, this is my terminal, this is the result, and that's still vector B. All right, let's try 2C plus the opposite direction on B. So that's here to here. I have a terminal and initial lined up, so that's good. So I got my very beginning start, my very, very end. This direction is the result, and that's equal to A. Okay, you pause the video, try 12. This is plus the opposite. So 2D starts here, ends up here. Opposite of A, so I'm going to start here and down here. So the result, original beginning, very end, well, that's backwards of B. Okay, 13. See the parentheses? It's just like simplifying an equation. Start with your parentheses. What is the result of A plus B? Did we do that already? We did do that up at number 7, but let's do it again. So here's A. Instead of using the bottom piece as B, I'm going to use the top piece. So the result of A plus B from here to here is 2C. Oh, now we have like terms. So what's 2C plus another C? That makes 3C. So I actually can't even show that on my diagram because a third C would be out of the parallelogram. It would be C, C, C. All right, let's try 14. They don't give me parentheses, but based on what we just did here, I'm going to think of this operation first. And we just did it. So let's use that result, 2C. So now we have 2C this way minus 2C. Well, that's going backwards, so we get 0 displacement. We've gone nowhere. We are back to the original start. Okay, the next page, page 13. I think it's just one page. Yes, page 13 is your homework. Practice and check your answers in Drive.